Hello all. In the previous video we have learned the theoretical part of pointers. This is the concept: variable, pointer. Address of the variable is stored inside the pointer 0x0, which is the address of variable. If we print p, it will print the value of a pointer, which is the address of variable I. So ampersand I points to 0x0, p also points to 0x0. So let's verify this theory in program. So we have created a project in code blocks. Right now we do not need this stdlib standard lib library. I will delete it. So let's create first variable, which is integer I. Let's initialize this variable to some value. I is equal to 11. Now we will print the value of both things. The value of I is equal to %d, let's say I, and now I'll copy the statement. Let's print the address of variable. Compile, run. You can see that the I is initialized to 11. I is a label, its value is 11, and the ampersand I is going to print the address. So this ampersand I is the address. In our program, this ampersand is representing the address of variable I. Now let's create a pointer variable. Integer star p creates a pointer variable. We will assign the address of I variable to pointer. Pointer variables are designed to store the address. Now we will use the printf statement, and in this we will say the value of p is equal to, and we'll print the value of p. See, let's go to the Excel. We have assigned ampersand I to the p, so it has initialized the value section of p variable. The value section of p variable is initialized to the 0x0, which is the address of I variable. It means that ampersand I and this p must print the same thing. Let's try. Compiled, run. It's taking some time. It's okay. You can see that the I is initial. I has the value 11. Ampersand I is to some number, and if you can see, this p and the value of ampersand I is very same. These both values are same. Now let's go and print the ampersand p. So now we have printed p. Let's print what is ampersand p. So instead of I, let's replace it with ampersand of p. Now let's compiled, let's run. Here you can see that this is a different address. Carefully look at the addresses. Ampersand I have some address 6356732. This address is the value of p, so p is equal to 6356732. Also we have ampersand p, which is address of the pointer variable 6356728. So this value is different than the value of pointer. So it confirms our concept. So pointer variable have a value as well as its own address. So own address is a different and the value is different. Now we are not interested in this accessing this value, which is the address of I. We are interested in actually accessing the value stored by this address. So let's do it in program. Printf the value of star p is equal to, and now we will print star p. So let's compile, program compiled. Let's execute. Oh, I haven't printed, sorry. So star p percent d, star p percent d. So let's compile and run. So here you can see that the star p, which is the asterisk symbol or a dereferencer, is also printing 11. So what has happened is we have I variable. This variable I is a label, 11 is its value, and this is address of variable. So p is assigned to the ampersand I, which is the address of I variable. So it becomes the value of p. P also has its own address, and if I say dereference p, dereference the value of p. Value of p is the address of I. So if we dereference it, it points to the same value which is stored in variable I. So this is the concept of a pointer variable. So we have pointer, dereferencing it will access the content stored at this address. What is the content stored at this address? So let's go to the address first. Address is this, and the content of this address or the value of this address is 11. So when we add star symbol, asterisk symbol, or a dereference symbol, it accesses the content pointed by that pointer, or accesses the content which is pointed by the value of the pointer, which is 11. Hopefully you got this concept. We will revisit the pointers in more details in the next video.